Alright, maybe this is working now. I never know. One of these days I'll maybe watch a video and see what the first couple seconds is like. Until then, I'm just going to keep jabber until I get the confirmation. There we go. Alright, hey, how's it going? I hope you're having a good Monday. I'm running late again. I've been sleeping in lately. Let me fix my screen. Whoa. That was not what I was trying to do. I have a tool for sizing. There we go. Sizing my windows appropriately. Let's see if this works here. I got this new mouse and it's like too good for me. It's like too exact, too precise. Alright, I am not having any luck with my sizing, so let's just do this the old-fashioned way. There we go. Alright, so let's get down and do this problem. It's called Contiguous Array. And increase my font size a little bit. Hopefully it's a little bit easier to read now. Given a binary array. Not a byte array, a binary array, so I'm assuming it's ones and zeros. Find the maximum length of a contiguous subarray with equal number of zeros and ones. So if you give me a 0 and a 1, and a 1, I should output 2 because that's the size of the longest contiguous subarray, which has both a 0 and a 1. Now, if you give me a 0 and a 1 and a 0, I should say 2 again because we've got a 0 and a 1, and that's it. This other 0 doesn't count. So that is definitely an interesting problem. I need to think about this for a sec. I don't know that I've ever encountered anything quite like this. I assume they don't have to be in any particular order. In fact, they tell us right here, either one of these would have worked, 0 and 1 or 1 and 0. And they don't give us any tougher examples, but it's not hard to imagine one that's tougher. So this is already kind of sounding a little bit like maybe a dynamic problem where I can kind of separate this into smaller subproblems. Basically, it's easy to find 2 that are equal next to each other. Given 3, it's easy to tell you that as well. Given 4, same deal. So what I'm kind of getting at here is basically if I kind of divide and conquer this array, then I can find, hey Vic, how's it going? Then I can figure out basically if I can combine the subsections. But you know, the more I think about that, that's not really true. I don't think divide and conquer is going to help us at all here, because we could potentially have some numbers on the seams. What I mean by that is, like, if I split up 2 subarrays and it looks like, say, 0, 1, 1, and depending on how I split that, if I have 0 over here and 1, 1, I would tell you that both of these are imbalanced. But when I put them together, all of a sudden they're balanced. So I'm worried about those guys on the seams. So still trying to think about what to do here. What else could I do here? Really, to know if we have a contiguous array, I really just need to know a count of the ones and zeros. Another way to say that is really just a count of either one. So if I tell you you've got 10 total, 5 of which are zeros, then I know it's balanced, because the count of zeros is equal to size of the array divided by 2. And I do have to worry about this being an even number. So you'd say array mod 2 and equals 0. And the size of the array divided by 2. Well, I wrote this very poorly, but hopefully I'm getting the message across. So let me write that a little better pseudocode. The array is call it is balanced equals array mod 2 equals 0 and 0 count is exactly equal to, or sorry, 0 count is exactly equal to the array dot length divided by 2. Oh, hopefully that makes sense. So that is an equation I feel good about, but I'm not totally sure how to get it to actually solve this problem now, because I've got an array coming in and I really need to look at slices of that array, and I don't want to do redundant work. So I'm trying to think about other algorithms that might have been kind of similar. Again, I'm guessing this one's easy, but it doesn't feel like easy to me. Like an AMA, I've never done a video like that, but if that's something you're interested in, then sure. I mean, I may plead the fifth or something would incriminate me, but yeah, I would do that. I would love to get the whole coding box crew on here and do that. That would be cool. Also, if you have any questions, you could just ask. I thrive on chaos and distraction, so it's all good. So I'm just going to come up with a contrived example here. I like this one because it is balanced. It does have an odd number, and it's just kind of interesting. So if I were to kind of, as a human, decide what the biggest substring was, then I would look at every possible combination. So if we consider the permutations of an array and basically looked at every combination, we'd be looking at an n squared algorithm, which is awful, because we'd be comparing everything against everything else. And so I do feel like that would solve the problem. It just terrible. So normally when I see like array problems and they look like they're going to be unsquared or brute force, then my first inclination, I've been coding for like 18 years professionally, something like that. And I still have some problems with some easy problems on LeetCode. I am new to LeetCode, and I'm hoping that by doing these problems and streaming it, that I'm eventually going to build that muscle, get swole, and get to where I can bang these things out in just a few minutes. That's the dream, anyway. I guess we'll have to see if it actually happens. I've gone through kind of phases where I've done like a couple months of like hardcore kind of algorithmic study, and at the end of those, I would definitely be kind of sharper with stuff like this. But it's been a long while since I've really tried to kind of practice like that, and it's not very much fun. So I've definitely been enjoying kind of being a little bit more casual this go around, and I don't have any particular goal in mind. I'm just kind of having fun. That's why I'm on here chatting and not like sitting here with a stopwatch. But yeah, to answer your question, like 18 years. Though back when the internet was new. So yeah, terrible runtime for the brute force. I'm gonna just X out the things that I consider and then don't actually go with. So sorting, not gonna help us here because it's important that I maintain the length of the substring, or the original order of the substring, I should say. That also eliminates some certain data structures that, or does it? So there are data structures like binary trees that I can use, and I can maintain the order of the elements such that I can retrieve them. And let's think about that for a second. So put trees, binary trees. And when I say binary trees here, I mean just because it has 2 children. It's like a common way of doing trees. You know, if you only had 1 child, then it's essentially an array. Not very interesting. But let's take our example here of 1, 0, 1, kind of look at what that would look like. So 0 would be the root. 1 would be the child, and 0 would be a child. So at that point, I could write a recursive algorithm that would go through and basically tally up whether or not something is balanced, or I guess I would just have a tally of the 1s and 0s. So I would not start at the root. I would start, I would do a depth first traversal. Go to this first element here and say, hey, how many 1s and 0s do you have? And the left child would tell me I have, this is awkward to write, 1, 1, and 0, 0s. And we go up to the root, go back down, and ask the root's right child, how many 1s and 0s do you have? It has no children, so it can answer easily. I went to college for a couple years. I did not ever graduate. I was a senior, though. I did take, I think, all of my computer science classes, but I still had some math classes and some science classes that I never finished. The college that I went to required you to take a lot of math and science classes. You ended up getting a math minor by the time you graduated. And by that time, I was going to college. I was actually working. I started working kind of early into going to school, and I was, programming stuff. Hey, Dave, how's it going? And so I stopped caring as much about school. I wasn't a great student, and I just focused on work, and I'm not sad about it. I've been happy with that decision. In fact, I wish I would have started early, but that's me. That's my experience. I can't give anyone else any real advice on whether or not that would work for them. How do we feel about the solution, though? I think getting this into a tree is going to be awkward, but if we do that, I think it's really easy for us to count up the 1s or the 0s, and then at that point, basically we can kind of keep track of the ones that are balanced and be able to kind of keep the biggest one. Let's see what our actual result here is. We just return the size of the greatest subarray. So if we look at this one, we figure out that our left child has 1, 1 and 0, 0s, and our right child has 1, 0 and 0, 1s. So that does mean it's balanced. So at our root node, we can now say, yes, it's balanced, and the size is 2. And really, that's all it is to solving this problem. So that's a kind of a small algorithm because it's recursive. It's not going to be very complicated. So to kind of pseudocode this thing out, what we have to do is basically convert nums to a binary tree, and then we'll do a depth first traversal. Call that DFT, and we will count the 1s and 0s. Yeah, I'm definitely not one of those top coders. Those top coders would do this problem in like 10 seconds. The people that are at the peak of their game it's just insane. People do like hundreds of these problems when they're going for like an Amazon or Google interview or something. And I ain't looking to do that. If you are looking to work at one of those kind of top FANG companies, then this kind of stuff is critical for the interview. If only day-to-day working life was so interesting, though, unfortunately. There's a big disconnect between, like, the interviews. Oh, hey, MEM. Hey, thanks for the podcast. Glad to stop by. Just hanging out, casually solving, I hope, some problems. So I think if we convert to a binary tree, then it's going to take us, figuring out the runtime here, it's going to take us the big O of n to go through every item in that array and convert it to a tree. That also means that our space complexity is going to be scaling with our input, which is unfortunate. We're basically going to have the same copy of this data over again. So not great, but if you remember our brute force solution was n squared, then we're looking at pretty good. Looking pretty good here. Now we do have to actually sum up the numbers, but I think that we're going to be able to do that as we're building up this tree. So I think we're going to be able to get this to a big O of n. So this is going to scale linearly with the input, which is pretty good. And I don't think there's any way to get it faster than linear time. The only time you can ever get problems down to linear time, sublinear time, is basically if there's some major shortcuts you can take to only look at a small fraction of the data in order to solve the problem, and that's really rare. Searching in a sorted array is an example of that, but it requires that array be sorted to begin with, and so problems like this, it's very rare to get any better than n, so I'm happy with that. Now the space, that's not great. With a problem like this, it feels like there's solutions where there's definitely solutions where you can even just brute force this and not take up any more memory. So we are sacrificing some space here in order to get this runtime. That's unfortunate, but that's a trade-off that I'm willing to make. I bet if we go look at the good answers after I work through this, we'll see that someone has figured out how to do this in n time and with a space of 1. 14, you're looking at binary trees in JavaScript? All right, man, raise the roof. Good job. See, when I was 14, I was playing Final Fantasy VII when it first came out. Playing it a lot, too. Oh, sorry, it's my phone ringing. It's going to keep doing that. Let me see if I can... Hey, thanks, Silvic. Glad to hear that. Yeah, Dave, I think that's a really good point. Like, if you can kind of talk while you're doing this stuff, then it makes a world of difference, and people will bail you out. So if you start going down just a crazy path, or you're talking about something that doesn't make sense because you didn't quite understand the problem, then they'll usually throw you a lifeline. So actually, that's a big part of why I'm kind of streaming this stuff, is because I wanted to kind of practice, working with distractions and working while talking through solutions, and just practice, practice, practice. Oh yeah. So converting numbers to a binary tree. You know what? I think I just figured something out by talking with y'all right here. I think that we can do this with a tree without allocating any new memory. And I'll show you why that's the case. So if we have an array of just some all right, some random data here, ones and zeros, then another way to think about this data is as if it were a tree already. What I mean by that is, think of this as the root. The next two elements are its children. The next two elements of that are the children of the next node, and so on. This would actually be, I ran out of room here. So kind of like this. So it's not easy to read. Oh my gosh. All right, yeah. So all I did there was just add spaces. So I changed the way I thought about the array, but I didn't have to move anything around. And we can come up with a math formula basically for every node to find its children. And from any node, we can use a math formula to find its parent. So what that means is we can treat this nums like a tree with some basic algebra, and then we don't have to allocate any more space. And I think we'll be able to figure this problem out in linear time. So this might be a winning algorithm. This might do really well in the numbers here. It'll run fast, and the memory will be good, which means I'm probably making some sort of mistake I haven't thought about yet. Let's give it a go. A 2D array would kind of sort it visually, so that would be kind of an easier way of like kind of me as a human thinking about the problem. But I happen to know a little bit about storing arrays or trees as arrays. In fact, because last night I coded a heap, which uses this trick. And so I happen to even remember the formula for parent and children. That's kind of what I was saying. Like when you're, when you're practiced on this stuff, then it just flows through you because you've got it like on the tip of your tongue. So last night when I did a heap, you do the same thing. You store the heap, the tree, in this data structure, same way. And so I know that a child element, if I said, get children for some sort of element, I know those children are going to be 2 times my index. So that'll be, we'll call this index of parent index, sure. It's going to be 2 times the parent index plus 1 for the left child, and the right, my phone is just going nuts today, sorry. The right child will be just 1 greater than that. And to get the parent in this structure, and we'll double check this, say child index, it's basically the reverse, which is going to be either the math.ceiling or the math.floor, I forget which one, of the child index divided by 2 and minus 1 for basically this kind of outlier that we're going to have here. So it's divided by 2, undoes the divide. The ceiling gets rid of one of my kind of hangers-ons, and the minus 1 gets rid of the other one. So let's double check this. So if we pull this array back into the shape it originally was in, which is 0, 0, 1, 0, 1, 1, and I say, hey, get the children for 0, the children indexes, make that a little bit better. Parent only returns 1, then it's going to be indexes. This is going to be cool. So get children indexes of 0 is 2 times 0 plus 1, or 2 times 0 plus 2. And if we look at our array here, that's going to map to elements 1 and 2, because we're 0 based, which correspond to 1 and 2. We'll try one more. So we'll say 1, this is index 1, and the children we should get back should map to the 0, 1 here, which this is confusing because it's all binary. That's annoying. But it should correspond to these 2 right here, which are going to be indexes 0, 1, 2, 3, and 4. So the answer I want from this is 3 and 4. All right, so 2 times 1 is 2, plus 1 is 3, and 2 times 1 plus 2 is 4. Bada bing, bada boom. All right, let's double check this parent index. So if I say, what's the parent index of 3, I should get 1 now. So 3 divided by 2 is 1.5, and I'm saying take the ceiling of that, so it's rounded up to 2. Minus 1 is 1. Okay, so that's good. And if we try the same thing for 4, we should get the same answer. 4 divided by 2 is 2. No rounding. Minus 1. Oh, sorry. 4 divided by 2 is 2. Minus 1 is 1. So there we go. We've got an array that we're treating as a binary tree. And the tree isn't growing, so we don't have to worry about any of that stuff. It's just how we're thinking about the data. Oh man, Vic, I so wish it did. There's some stupid errors I've spent so much time on. And when I'm using an IDE, I don't have those problems. I'm not used to them. All right, so man, I've made a real mess here. Let me clean some of this stuff up. Efficient answer. So we're just going to skip over the brute force solution. It's I think it's even going to be more annoying to type. We don't have to convert our numbers to a binary tree. We've already got it. So now the hard part. Let's see here. I guess I don't need that stuff anymore. Now we have to actually traverse through this array, depth first, and we're going to associate or store some data about the nodes. Unfortunately, the way I was planning on storing that data is going to be per node, which brings our space back up to n, unfortunately. So I no longer think we're going to have an award-winning algorithm here. I think it'll still be good, but we're not going to win any prizes here today with this because of how I'm planning on counting. Maybe someone figured out a way around that, but I'm not seeing one off the bat. All right, so we're going to depth first traversal through our tree. We'll count the ones and zeros. So I'll put that on a separate line. And we will save the count we will save the count to a new array. All right, and up here where I said count the ones and zeros, it should really be a little bit more complicated than that. So what we'll say is return count of one or, we'll say return count of 1 or 0 if this is a leaf node, so if no children. Then that will be our stop condition too, so we don't just go on infinitely. And then if we do have children, it'll be basically return whatever the results of the depth first traversal is. So we'll call that left, to go to our left child, plus the right, plus our current. And we'll associate that to that new index in the array. And then at the end, we will find the biggest item in that array. We'll return the biggest item in the array. So if you have 2 loops in the code, it could be either way. So if you have a loop within a loop, then it's probably going to be an n squared algorithm because you're looping over every item for every item. There are some algorithms that are smart about like hopping out or breaking early that can change that. Ah, man, I've heard great things about TypeScript. But the kind of the funky thing about big O notation is if your loops are at the same level, meaning they only loop through the input twice and not a multiplier of each other, then the big O runtime is 2 times your input size. But because big O is an approximation, you drop your constant values because they don't contribute massively to the growth of your function as the input increases. So you drop constants, which is goofy when you think about it, because what it's saying is like, that's a big O of n, and so is that, and so is that, and so is that. So it doesn't matter that we're looping through our input 6 times. Because it's a constant number, it drops out of the big O calculation because we're only concerned with basically the growth of that function over time. And so those constants eventually kind of fall out and don't matter as the input gets increasingly large. But in real life, this can have a big performance impact. And so big O is not the end all be all, but it works most of the time. And so right here, I'm talking about basically looping through the array again. That's not going to affect my big O, but it is inefficient. So we'll probably figure out a way to get rid of that as we go along. I think that'll be easy. All right, so we got our nums. I don't think I've ever done a depth first traversal on an array, tree stored in an array. So this should be interesting. I think I might just go ahead and make these real functions and just use them as helpers. So if I say, I don't really like var for things that don't change. So this is a function. And I'll just do it like this so I don't have to type very much. Are semicolons optional in TypeScript? I've gotten kind of used to not typing them. All right, and get child indexes. What I'll do here is return, or you know, we could do it this way. Just an array of 2 times parent index. Yeah, those n log n ones are really tough. They almost always involve some sort of like crazy optimization. Let's see here, what did I do wrong? All right. So child indexes, we'll just call that child indexes. There we go, get parent index, there we go. Yeah, man, I struggle not entering the semicolon. I've started doing it though. I do think it reads a little cleaner. Kotlin also doesn't require a semicolon. The IDE encourages you not to use it. Prettier, the plugin I use for JavaScript, also discourages using a semicolon, so I've just stopped using them. For better or for worse. All right. Yeah, I hear you, Dave. You know, the whole reason I'm even using JavaScript is because I couldn't beat them, so I joined them. Yeah, so Justin, I definitely don't do stuff like this in day jobs, unfortunately. So for me, it literally is just kind of flexing a muscle. Sometimes it comes up. We'll have some sort of tree problem, and the people who aren't familiar with doing these kind of challenges tend to kind of make a mess of things, I would say. But I mean, that's like, I don't know, 1% of the time. It's very rare. I would say that much more common is dealing with problems with like inefficient data lookup. So going to databases more often than necessary, or calling services in a bad way. And so it's like that network latency or those disk lookups that ended up being so much more important, in my opinion, than the big O kind of time. Because depending on the kind of work you're doing, this stuff just doesn't come up. Like we typically don't deal with arrays that are, you know, hundreds of thousands of lines large. So like the big O growth functions just don't really apply that often. I know some people definitely get upset when I say that, and you know, maybe they're right. But that's my personal opinion on it, and I think you'll find it's a popular opinion. So I don't know, I mean, it would be fun. I work with graphs a bit, but even then it's usually kind of like simpler, not huge, crazy problems. All right. Sorry, my dog is bugging now. All right. So depth first traversal of an array. I don't even know what this is going to look like. I've never even considered doing this in an array. So we'll have some fun here. So I wonder if I could say, set a current variable equal to 0, which is our root. We'll say We'll do a do while loop, which means we'll run at least once before we consider our input, which means if they pass us an empty array, then we'll have an error. Yeah, JavaScript is worthy of love. I agree. It's definitely worth learning. It's good. It's just, there's some quirks about it that are frustrating, and I'm sure I'll complain about it at least 3 more times before this problem is solved. But I mean, all languages have their warts, so that's just how it is. Yeah, totally. I agree with you. I mean, I've seen more performance problems from like JavaScript developers that bring in like node modules for, you know, left pad or something that was kind of not necessary, or they brought in some module to solve one little problem, but they brought in this big module, and so it ends up bringing the whole page down. That's usually much more of a practical problem than like binary tree stuff. Oh, yeah, that's the world we live in. Somehow this is still like the king of interviews, so I don't know why. I guess those big companies seem to know what they're doing, though. Like the fangs of the world, like they're doing this stuff for a reason, so I guess it's working for them. I do enjoy quite a bit of nonsense myself, so I hear ya. So while current is less than nums.length, because we don't want to go past the end. And I'm still not even sure I really like this. I'm still kind of not really understanding how to iterate through my array here. So I guess I should probably take a step back before I keep coding and make sure I understand the problem. And you know what? I'm not going to do ones and zeros because it's just confusing to me. And 9 and 10. Okay, and so, you know what, let's do one even better. Let's draw this out like a tree so it actually makes a little bit of sense. Yeah, you know, sets have been out for 4 years, and I still get confused about like set syntax and stuff. 046. All right, so this will be the tree that we work with, and this will be how we want to iterate. That's not true. Hold on. We're doing a depth first traversal, sorry. So the order that we want to visit nodes is 4, 3, 1, 2. So we'll go 1. We won't count this one yet. 2, 3, 4. We'll just do 5. All right, let's see if this happens in the right order. Yeah, NPM or NPX or yarn. All right, so this is the order that we want to visit this tree. And so the array that we actually are going to be dealing with is going to look like this. 4, 3, 5, 1, 2. So this is our input, and we need to make sure that we iterate through it like 1, 2, 3, 4, 5. Oh my God, go lay down. All right. So what we do is we start at the root, which is index 0. Okay. And then we go to its children. So we call getChildIndexes, which is going to return a 1 and a 2. All right, so for our next kind of frame in the stack here, we're going to look at this item. And from there, we'll get its children indexes, which are 4 and 5. Is that right? I have to run this again. So 2 times the parent index is 1. So 2 plus 1 is 3 and 4. Okay. So 0, 1, 2, 3. oh, sorry, 3 and 4 are the indexes we're looking at. Okay, so when we look at index 3, I don't know many JavaScript backend developers, but I know a couple now. Zach Brady is awesome, awesome coder, and he's a JavaScript man now. He's at U.NET. So I don't know, man. Maybe the times are changing. So we look at index 3, 0, 1, 2, 3. It has no children because that would exceed the boundaries of the array, which is what I was trying to check here. So now we can just return its value. So that looks pretty good. All right, so then we're going to come up here. We're going to look at index 4. And if we try to get its children, it's going to be 4 times 2, 8 plus 1, 9, which is definitely bigger than the size of the array, which is just 5. So we would just return 2. All right, and now we've called both of its children, so now we can, we're back here, so we can just say, hey, return 3. Okay, and we get back up to the 0, and now we're going to go to the second index here, which is this guy. So now we're looking at 2. Heck yeah, man. So we're looking at index 2, and that is the 5. It has no children, so we just return. Oh, I forgot one. I messed up my sample data. So this should have been 5 and this should have been 4. So here we should have returned 4. So cool, this algorithm works. So this is how we can do a depth first traversal in an array format. So just to kind of pseudocode that out, what I'm going to do is I'm going to break this out to a function. I'm not going to try and do this iteratively, which again is a warning sign. Anytime you go to recursion in a problem like this, there's nothing wrong with it, but you have to know that your space complexity is likely going to go up. And anytime you can do recursion for a problem, there is, I can't say this for 100% sure, but there is usually a way to iterate and get that same answer. It just sometimes the iterate is a lot harder to code, so that's something good to kind of remember in an interview. If you're doing recursion, it's worth calling out that you run the risk of like a Stack Overflow and allocating a lot of memory, and that's something you might be able to avoid. So let's call this function, I don't know, depth first traversal, and we'll take a node, call it index. All right, we're almost here. Sorry this is taking so long. Yeah, yesterday it took me so long to solve the problem, and I thought I'm not going to do anything weird today. And here I am trying to code up a depth first traversal of an array instead of just doing the brute force solution. So I'd like to tell you this is unusual for me, but I wouldn't want to lie to you. All right, so we've got an index. So all we're going to do here is call get child indexes. Oh man, I've killed some kittens. All right, so we'll get the children. And if, well, what do we want to do here? I'm just going to worry about traversing here, and then we'll worry about counting later. I think we'll probably end up worming that into here. Okay. What am I doing? What am I doing here? What do I want to do here? That's a good question. Still thinking about it. I keep getting hung up on what I want to do next, and I'm losing track of what I want to do now. They do, but it's pretty minor. It's just going to be an extra pointer, so like an extra 32 or 64 bits. So it's no worse than like declaring a variable, like a temp variable or something that you don't need. I'm going to do this, left and right. We'll destructure that thing, get my children. So now what I want to do is kind of what I said in here. And yeah, I'm drifting off. I've entered implementation details of the actual algorithm. I can't help it. If left and right, oops, if left is greater than, I need to know the size of my array. So let's go ahead and just pass the whole array. If left is greater than nums, greater than or equal to nums.length, and right is greater than nums.length. All right, catch you later, man. Enjoy that ice cream. Ice cream is my weakness. All right, so if we do this, then we need to return the counts. So we are at a child node, so we know it's okay to just return what we got here. I'll return an array, sure, and we'll have a value that represents the count of either the 0th or the first item. So we're dealing with binary, and this is kind of convenient. So what we want to do here is the 0th element will be nums at left. No, sorry, nums at index. If nums at index is equal to 0, then we're going to count its 0th element. Otherwise, we will do 0. And here, other way around. If it's equal to 1, we'll count it. Otherwise, 0. Dude, vanilla. I swear, I love vanilla ice cream. It's my favorite. Strawberry is up there too, though, and so is chocolate. Now, if you got a birthday cake flavor ice cream, that is the ultimate winner. Maybe a peanut butter too, cookie dough, but vanilla, man. All right, so I think this is good. That's the first chunk right there of our algorithm. All right, next part. So, what we want to do is return this call. We'll ditch this. Velveeta? Velveeta ice cream. I figure it meant velvet. Velvet, red velvet cake, man. Ice cream, that sounds lovely. But also, if you had some Velveeta ice cream, I'd try it. It's not cheese, I don't know what it is, but I would eat it. So we're going to return this call. We're going recursive. We got our base case in, so God's not killing any kittens tonight. Whew, not on my watch anyway. And we're going to pass our array as is, and we'll pass left. Now we do have one more thing to worry about, which is the case where either left or right is empty. In order to do that, we need to do the same kind of check for our current index up here. So we almost did hurt a kitten. And I love cats. So not cool. Okay, if index is greater than nums.length or equal to it, then we can just return 0, 0. Ooh, that's a tough one. I don't know, I like spongy cake. See, we're pretty much doing an AMA right now. You don't need nothing official. All right. So that's good there. So if somehow we get past this check, that handles a good condition that would have broke us in a minute here. So we're returning our left results. Or here, let me do it like this. Const left results equals this. Const right results equals visiting the right. I am a big fan of Star Wars. Let me see. If you look back on my shelf, you'll see, it's hard to see. I got a couple Yodas up there. I have several Star Wars toys, but I think those are the only ones upstairs. So we got our left results, we got our right results. Now we do have to worry about the case where we've counted our left and we've counted our right, and now we have to count our self, which is this right here. So we'll call this my values. Sure. Or how about current values? I don't like my for some reason. All right, and then here we'll just return current values. Otherwise, now we need to apply all these together. So our result will be current values at 0 plus left results at 0 plus right results at 0. Is this making sense? Okay. So, I think that's pretty good. We'll change this name to depth first count, because we're not just doing a traversal anymore. We're not returning nothing. Okay. So, down in here, one more thing I gotta do. Pass 0 for the root. Clear this junk. So, this is going to return everything. So I'm not checking to see what the balance is right now. So I'm going to pass a third variable. Feels yucky, but I think I'm okay with it. Called max balanced. All right. And that means I also need to curry that that variable on when I call depth first count here and there. And here I also need to pass my nums. And I'll start the count at negative infinity. All right. And so what we need to do is check if these two are equal. So we'll call this result. We'll return the result, so we haven't changed anything yet. I do technically prefer Star Trek to Star Wars, although realistically I haven't watched nearly as much Star Trek as Star Wars, so, you know, in theory I prefer Star Trek. If result at 0 equals result.1, that means we have as many zeros as we do ones. Then do this in an if, and result at 0 plus result.1 is greater than max balanced, then we can set a new max balance. Okay, so I am a little worried that this is in the wrong spot because I checked the max balanced down there, but I passed it up here. So I'm wondering, I mean, this is where I need to calculate it. This will never be the answer. Do I have to worry about this case? You know, I don't know. I think we've got a logical loophole here. Let me think about this. We might be able to solve this in another way. So I only change max balanced here. And what's bad about this is I'm treating this like it's a local variable, but I can't actually compute it till we get past that. So basically the way I've got this written now, I changed max balance, but since I'm not returning it, this isn't passed by reference. And so, oh boy. Yeah. I think you're right, Dave. I think this might work out okay. I'm just afraid that we're never actually going to change the value of maxed balance here. And so I think we're always going to end up getting, like, I have no way to get this back, you know? Oh. Doi. Here's what we can do. And we're already passing a complex object, right? We're already making a mess. Why not make a bigger mess? Here, instead of passing back 2 indexes, we'll pass back 3. So in this case, actually we should probably just maintain max balanced like that. Down here, when we return current values, we just need to add a third variable here for max balanced. Okay. And then down here, we set max balanced. We'll just set this to max balanced for now. Then what we'll do is we'll set a new max balance. So result at index 2 equals that. And we return result. Okay. Now let's see what happens, Katie. Const result equals that. And what we're going to do is we're going to return result at index 2, which will be our max balance. Now, this is going to be a syntax error for sure. I haven't run this in a long time. What? That never happens. I typed all that without a syntax error. I should get an award or something. Can we get some applause? Oh, thank you, thank you. Okay, wow. Well, let's try their second example here. Let's see. Ooh. Somehow I ended up returning negative infinity. The reason I like setting negative infinity instead of 0 is because when it falls through like that, then I know a little bit about my code. I know that the case never hit to change max balanced. So it means it wasn't this one. Or so I know it was this one or this one, and that I never fell through to here. So why did that happen? So the problem text case that we had was 0, 1, 0. I don't want to trace that out. Let's just log some stuff. We will look at our index, sure. Try to make this read intelligibly. Nums at index equals sure, nums at index. So that'll make sure that we're looking at the right element. Okay, what else do I want to see? Dot log, we'll do the left and the right. Hey Ryan, welcome. Live may be a bit of a strong word, maybe undead. Sorry. Cheesy. If you've caught any other ones, you know I have a bad habit of going for semi... no, it doesn't have debugger. It's semi-extravagant solutions, and it looks like I've fallen into the same trap again. Let's see. Left index is left. And so what I'm trying to do, Ryan, is basically we've got a problem where we're trying to count the maximum balanced contiguous subarray. And so the way we approach this problem is by treating this array as if it were a binary tree and then counting up the ones and zeros for each node and its children underneath. And I think we've got that all coded, so we're basically just debugging now. But it does mean that my LeetCode solution is like all depth code traversal, depth first traversal, and then that's it for the actual like kind of main function there. So all the work is up in here, just doing depth first and just doing some math. But I think it's got a little weird. They got a little hairy down there, so I've got a bug somewhere. No surprise. The first test case worked. The second one did not. So I'm just casually adding some console.logs. Do we care about this? Sure. Log index out of bounds. Returning 0, 0, and whatever was in max balanced. Well, let's see if that's enough of a hint. Yeah, Dave, me too. Me too. That's just a jerk thing to return. I mean, JavaScript makes it easy to return an object. I could have done that. And I'm just being a jerk. So we started at 0. We figured out the left and right, correct. Nums at 1 equals 1. Yes, it does. Nums at 2 is undefined. Huh? Why is nums at 2 undefined? Oh, I was looking at the wrong problem. Here, let me, I ran this problem twice. Her. Let's try going. Try doing this. All right. I'll put a, sorry, Dave. frowny face. If you put in comments in code, and it excuses any dirty stuff that you may have done. It's a little trick I picked up from clean code. All right. Left index is 1, right index is 2. Num index of 1 is equal to 1, yes. We figure out its children, fine. Num index of 2 equals 0. We figure out its left and right children. And then I got lazy and stopped logging because I was hoping to be able to see it just from that. Okay. All right. So now we're saying current values are, put it in brackets, current values at 0. Oh my gosh, I am kicking myself for doing this array. Oh, I'm gonna have to type my shame out here multiple times. So sorry, Dave. That's our current values. Let me name it consistently. And down here we can say, hey, we ran out of room. We ran out of children, returning current values. All right, and here's the last case. And what we said is that if the result at 0 equals result at 1 and 0 plus 1, so basically counting the zeros and the ones, are greater than max balance, which is negative infinity, we're going to say, yay, we have a new max balanced. And we'll put that value in there. Otherwise, we'll say, I don't know, aw dang, we are keeping the old max balance, and we'll print that out. All right, and so let's see what this looks like. Okay, that looks good. Current values are fine. We counted a 0. We did not count any 1, so that's correct. Okay. Now we went up, we went to this first child here. We said left index is 3, right index is 4. That's cool. Current index, current values for it are 0 and 1. Yeah, cool. And infinity, sure. Now we ran out of children. This one doesn't have any children. That's fine. So it returned this number up to the root, this result. Okay. And right now that's balanced. Oh God, I solved the wrong problem, didn't I? I solved the wrong problem. So right now, right here, we should be able to see, oh hey, if I add these two together, it's balanced. We have a new max balance. But instead of doing that, I went on and looked at the next item and counted it up. Infinity. So we say we ran out of children, returning our current values. And that's the correct thing to do. We kept our old balance, max balance, which is correct because this condition was not true. So that's okay. It doesn't need to be true. What does it need to be? Okay. So here's what we're going to do. We know the left, we know the right, we know our own. So all we have to do here is basically just see if our left and our right, or rather, if our left or our right are balanced with us. So what's the best way to write that? So this is the question of whether me and my children are balanced. But I don't ask the question if me and one of my children are balanced. So let's just do another if here and try to get that working. We'll check this one first. So we'll do an else here. This is going to get ugly, I'm warning you. I like this solution less and less. Every 10 minutes that fly by. If result... No, I don't want to check result. Dang it. I don't want to check result. Let's just type this thing out from scratch. If R left results at 0, you know, oh man, this is just so ugly. All right, let's rename some things. We'll call this all together result. Yuck. It doesn't like Control F, I always forget. All together result. Yeah, Dave, you got it, man. I'm there. Okay. Then that's the case there. Oh my gosh, this is just not pretty. And then we'll return that there. All right. Wait a minute. We were never returning. All right, that's fine. All right, might be. All right, return altogether result. Oh my gosh, this is so nasty. Do you know what I'm gonna do? Yeah, this is a walk of shame here, Dave. All right, my left result. Just this. You know, I wouldn't have to declare so many variables if I just did another array. Oh my gosh, this is so nasty. I'm so embarrassed that anyone is seeing this. This wasn't the plan, guys. This was never the plan. Maybe we can figure out how to trim it up, but I have a feeling that I am gonna never want to look at this again after I finish. Okay, if the left, whoa, equals that plus that, there we go. Max balanced. And we got one more to do. Gosh. This might, is there a award for the longest solution to a problem? Most lines? I'll tell you what I'm doing right here. It is wrong. There is definitely a better way to do this. I'm just like so far into the problem that I don't want to change how I'm approaching anything. So what did we get? We got the right answer. Did it do the right thing? Start at 0. Check. Check. Yeah, you got it, Dave. That's hilarious. Oh man, I would read that book. All right, 3 and 4, great. Okay. We ran out of children. Okay, we got a new. That's funny. We have a new max balance. That's what I told you in negative infinity, but that's not the right output. It should be. Oh gosh, here we go. Another walk of shame. This gives me a chance to double check to make sure I didn't typo anything. Man, so no lie, if you saw this checked into your source code repo, would it work? Ooh, Stockholm Syndrome. Yeah, for sure. Alright, so that's the right answer. Do we still have the right answer from the first variation? Okay, now I'm just going to type in some gibberish here. Okay. So we should almost never have 0. The only way you should ever get a 0 is if you only have one type. Runtime error, give me a break. Solution.js, line 71. I say return result. Huh. What should the result here be? It should be altogether result. And that makes me nervous. We didn't test this case before. What are the chances of it being correct? Not so good. Oh dang, we were keeping the old max balance. I literally set the new max balance right there to 2. It's also bad. And somehow did that anyway. Yeah, an empty array would break my solution. Actually, we have a case right here. So if you pass an empty array, it would come up here and say, hey, index is greater, index of 0 is greater than the nums, greater than equal to the nums.length of 0. So it would return 0, 0, and crap, negative infinity. So it this should not be negative infinity to seed. Good call. Good call. Should be 0. 0 or negative 0? Okay. Say. Thanks, Ryan. See, now you guys are immortalized in this walk of shame here. So we're all in it together. No ratting. All right. So why did that happen? How did I say we have a new one and then immediately lost it? How did that happen? Altogether result. Say, yay, we have a new max balanced. Okay, and then we set the altogether result, the left result, and the right result. We return the right item. Oh, I didn't say else. Jeez. Sorry, Dave, you're in it. You're implicated. Okay, hey. Better. How did this happen? I don't understand this. Yay, we have a new max balance of 2. And then somehow it either didn't get set or somehow it got reset. All right, I was hoping to come up here and see a 6 getting set. I mean, I don't see it until we've run out of children. Yay, we have a new max balanced 2. Did I mess up this paste? Left result, right result, right result. How does that number ever go down? I'm only adding. And it's only 1s and 0s. There should literally never be a way for this number to go down after it goes up. Oh, is it just... No, I mean, all 3 of these return. Man. Why am I returning the... This is boggling my mind. This is infuriating. Did I give something up higher? Left plus right? left, right. I literally couldn't see if there was a bug in this. It's all blending together. It's all together result. And each one gets returned. So if it returns, it should never fall through to here. Oh, look at that. Look at that. I get the left results. Depth first count. And then I just take max balanced? What sense does that make? I don't want to take necessarily max balanced here. Because what if my left results or right results, max balance is bigger? I guess that's what I'm checking down here. But that's how it's happening. I'm basically discarding the results that I got from here. So here I'm returning like a 2. But here I just take the negative infinity and then it never hits these use cases here to fix it. So I think this is okay. As long as I fix it down below. Current values, check. Plus left, check. Plus left. Oh my gosh, I'm so sick of this problem now. Plus altogether result. What? Okay, that's all right. Huh. What is the problem here? Maybe I shouldn't be so fixated on this last case. Just that's the only thing I really see that jumps out as to me as wrong here. But the right answer is 6. That's interesting. So I do show the current values. I guess I never really show the current values as I kind of add them up. So I would be curious to see what those are to see if it's even remotely correct. So I'm seeing a lot of really low numbers here. And we only ever set the max balance once. Oh guys, we're so close. Peeps. Peeps, we are so close. Alright, let's just log this out. Right result, I wish. Left result. The Last Jedi. Oh. It was good, you know. There's some really cool moments, some of my favorite moments in all Star Wars history in that movie. I don't want to, give anything away, but was pretty awesome. Also, was pretty awesome. So I did like that. There's some parts, What do you guys think of The Last Jedi? No spoilers. So we've got stuff logged. Altogether result. Okay. I thought this would somehow help. I don't know. I thought seeing more information would help, but it really doesn't. I mean, I guess it does help me to see that I'm not seeing the kind of results that I really expected to see here. Like, why are these so low? That's incorrect. Like, I'm never seeing the counts higher than 1 or 0. Yeah, I mean, Luke was my man, so I hated to see him go. But I didn't like him in the last movie, whatever that was called. So I was kind of happy to see him go, actually. He was kind of a jerk. Although I'm being a jerk with these arrays, so, you know. The fight scene was awesome on that like salt planet with the red. Yeah, not my favorite for sure. So it looks like none of my math is working correctly. I'm not adding up values correctly. Which doesn't make any sense to me. The depth first traversal is going great. We are returning items. When I call this stuff to get the left and the right, what do I call it with? I pass nums. I pass left or right. I get the results, but what I want to do is add those results for left and right with me. And there's maybe even 4 use cases that we need to check. So when we get our left counts back, it's either left is balanced and biggest, right is balanced and biggest, left plus me plus the the root, the current node is balanced and biggest. So it's 5 possible states. Left right is balanced, or the right plus root is balanced and biggest, or nobody is balanced, which I don't even know if that's possible. I think that's very unlikely unless you have all the same number. So why is this addition turning out funky? So if we look down at the logs below, I'm going to clean up some of this noise a little bit. I don't really need to see that, I guess. That's fine. That garbage is fine. So I run this thing. Current values are 1, 0, 0. For 1, the current values are 0, 1, 0, okay. But it never adds. Like, how come this and this never get added up to 2? Am I doing some dumb JavaScript thing? I've never seen Get Out or It Chapter 2, to tell you the truth. I don't know that I saw the first It. I used to read a lot of Stephen King books, but I just never saw It. I don't watch a lot of movies. I make exceptions for Star Wars. 1 and 1. How on earth am I not ever getting greater than 0 or 1? Is the problem up here? Current values is 0 plus this plus this. I mean, I kind of just want to see this. Like, this should absolutely increase. Dot logs will say come on now. Altogether results. I hate this because I believe the algorithm is correct. I just have a stupid bug somewhere. I think I say that every night, every morning, every day of my life. That's what coding is. Calling the computer wrong and being wrong. Over and over and over again. So hey, at least we saw a number bigger than 1 for once. Okay. So how is it that altogether result can be 210, but it down here we got 112. So yeah, maybe I'll put that up here. So all left or right. We're getting really close here. Well, this is gonna be something really dumb. Okay. Okay, current values for 0 are counting itself. That's fine. Yeah. Well, it's not my computer that's broken. It's LeetCode's computer. It's all computers that are broken. Can't they just do what I mean, not what I tell them to? Okay, so the altogether result is 210. But here we're saying we went left. And we went left because 2 is not equal to 1. So the altogether result is not correct. So here we said, oh, that's interesting. Left we have a new max balanced. And then after that, heck yeah, man. See, aren't you so glad you caught this in real time, Ryan? Tonight? I bet you this is classified as an easy, and I dispute that. I'm tempted to just start over and do the brute force and have like 2 for loops and be done. We might get there. We might get there. It could happen. Alright, so we do log the result that we return. So if I look and say like, hey, left, we have a new max. I saw that in here. Left, we have a new max balanced. So this is left, and left is balanced. Look at that. 1, 1, and a 2. That's good. Let me keep checking stuff. That's good. But I don't see. I mean, that even looks good. At least we're getting a bigger number there. Yeah, I know, it's a shame. It's a shame we can't just deploy from here. Can I just say it's good enough? Well, these numbers are looking better. I'm seeing additions now. But I'm seeing 2 problems. One, it's not adding correctly. Something is going on here. And 2 is that the max balance is getting reset here. Ah, jeez. You know, it's gonna be this gobbledygook in here. This stuff is just nasty. It just smells wrong, you know? So let's just put all these things together. Let's see, all left. Arrays are passed by reference. JavaScript. Am I doing something dumb there? I'm passing, I never mutate nums. So I think it's good there. I never pass the result, but I do pass the result ups. Oh man, if that's it, Dave. Is that it? So I get my left results. Do I ever modify them again? I do modify the altogether result. I do modify my arrays. Oh my gosh, if that's it, Dave. You know, I usually don't modify stuff. I don't like modifying stuff because it turns out like this. Oh my gosh. Well, let's see what these look like. You know, at this point, I don't even care what the current index is. I don't really care what this is. This is just tricking me. So, let's see what this looks like. Man, if that's it, that's going to be frustrating. I'll spend all this time like looking for some sort of like left where there should have been a right. All right, so we looked at 0, we looked at 1, 0, 1. We ran out of children. Returning current values. So we went all the way down to the bottom. And I'm going to draw this tree out here. This sticky note. Hey. Got other stuff in there. That could have been embarrassing. Alright, so our tree looks like this. Oh my god, I'm already regretting having such a long example. Okay, I hate this. This is a terrible idea. Why are we looking at such a long example anyway? Yeah, I think you're on something, Dave. Oh man. Let's see if we can get this in a shorter example. I've got it copied on my clipboard if I need it. Nope, so that worked. Try adding 1. Call this the granny method. Just delete stuff till it starts working. Or delete stuff until it stops working. Okay, so this item, so this one worked, this one didn't. Got the wrong answer there. So, is it an odd even thing? What happens if we go down to delete 2? So that would be much easier to trace through. Yeah, that's true. That's true about the objects. So that works. Try one more. Okay, that works as well. So, you know, without spending too long to go through and try to find a smaller example, this one is a little bit easier to reason about. It fits all on one screen anyway. So we got 0, 1, 1, 0, 1, 1. All right. So if we draw out our tree, 0, 1, 1, 0, 1, 1. Okay. So we look at the 0th item, and it has a child, so we move on. We look at the first item. It has a 0. It has childs, rather, sorry. So we move on. Now we look at the third index. 0, 1, 2, 3. It is a 0. And it is this 0 specifically. Okay? It has no children, so we return the current values, which I don't output here. So let me go ahead and add that here. Here. All right, let's look at this. Bring up our little tree here. So we're looking at 0. We ran out of children and we're returning our current values. And yeah, I am so kicking myself for this array, man. So we're saying we counted a 0. That's correct. All right, so now we go back up to nums of 4, which is going to be this one right here. And let's see here. Where does that live here? Having a be binary has definitely been confusing too. Oh, yeah. So this is 0, 1, 2, 3, 4. So this is the item we're looking at right here. And it also has no children. So it counts itself as a 1, correct. Max value is still 0, fine. Okay, now at this point we're looking at this character again. And we're saying, let's check you to see what your max balance is. All right. And in this case, we do have a 0 and a 1 here. So this is, I can see that there's already a problem. So we should have returned a max balance of 2 here. Oh, and we did. We saw that. That's correct. Okay. Cool. So in this case, it should have said, hey, if I look at all 3 of these combined and tally your results, you have 2 1s and 1 0. So you're not balanced. Now, if I look at you and your left child, you are balanced, and the result is 2. So that's our correct condition there. And then we looked at right, and we're comparing this one with this one, which is 2 1s. So boom. So we're saying, hey, left, because of left, we have a max balanced number of 2. That's correct. This is the correct number to return. The correct result. Oh boy, Dave. It's looking like you called it. So now we go up and we look at the second index, which is a 1. It's right here. It has a child, which is a 5. At index 5, it's the last item. Yep. It has no children. So it returns this value, correct? Okay. And let me go ahead and write down max is 2 here. That should be correct. All right, now we try to go to its right child. It doesn't have a right child, so undefined, that's fine. Index is out of bounds, so we just return all 0s. That's fine. Okay. Now in this case, we're looking at all left and right. Nothing is balanced because we have 0 0s in all cases. This branch is only 1s, and that's correct. That's good. So it's saying, oh dang, we're keeping the old maxed balanced, which is wrong. That's wrong. Or is it? I mean, the max balance thing that this has ever seen, it doesn't know about the left branch. So maybe that's my problem here. Is I'm expecting too much for it. It's never seen. It doesn't know anything about these guys over here. So why should it know about the 2? So really, that's good. So it returns a 0, returns a 0, returns a 0. Now up here, at this point, I know that 0 and 1 are a match. Oh boy. Oh boy. We got a problem, Houston. My algorithm will never count this. So there's not a bug in my code. It's that I solved a different problem, if that makes sense. Oh, geez. We just spent a half hour trying to find a bug that doesn't exist. All right, let's see if I can explain this. My code always kind of counts up and kind of bubbles up, but it never accounted for the case where a contiguous array could kind of go around the array like this. So in this case, the contiguous array is 0, 1, 0, 1. Is that right? So it looks a little funky because of the order I set it in, but we're looking at it basically right there. Oh my gosh. Trying to think if there's any way I can fix this. I don't know, man. I think I straight up done goofed this one. I don't know that constructing a tree really helps us. Did I really do all this only to realize there's a big glaring hole in my logic? I think so. Yeah, that is never gonna count. Oh, that hurts. Though, you know what's not gonna hurt is deleting all that garbage. So, where were we? Rewind. Okay. We got to find the max contiguous array of balanced ones and zeros. Order doesn't matter. Yeah, that was a lesson, man. It stings. I could be playing Overwatch right now. And instead I'm stinging. All right. So if I wasn't trying to be clever, what would I do about this? I would look at every contiguous subarray and I would just count the ones and zeros in it. And I think we can do that in a somewhat smart way. Dynamic programming, yeah. Ryan, I think you weren't here at the beginning, but I actually kind of thought about that. It's basically like, I thought about divide and conquer and kind of ruled that out because of the splits. And then dynamic programming, I think, is probably the right answer here. Basically, we're going to keep some sort of like tabular result and then kind of build it up as we go along so that we don't have to keep doing repeated calculations. And that's how we avoid doing n squared. And we keep the memory use low as well. It just, I have such a bad record with dynamic programming challenges. But hey, that's why we're doing this, right? For practice. But I am going to be really surprised if this is a dynamic problem that is ruled or is classified as an easy, because I don't think any dynamic programming problems can ever be considered easy by anybody in the world. So maybe they're kind of, I don't know. Maybe they're crazy. It's definitely them, not me, for sure. All right. So yeah, let's try to do this in a kind of a dynamic-y way. So I'm just going to kind of think about the problem a little bit here and see what we come up with. If I was trying to do a dynamic, I would keep a table of probably zero count and a 1 count. I hate that. So just to go the other direction, Dave, instead of doing an array, I'm going to do a 0 count and a 1 count spelled out. I'm a monster. writing out numbers in code. We'll write this table this way. And we'll iterate through our array. We'll take a look at this kind of use case they give us. I'm not going to do the commas anymore. So this is our example. So we look at the first item. Okay. 0 count is 0. 1 count is 1. Oh, sorry. 0 count is 1. Oh my god, I hate this problem so much. Alright. Now let's move on. So now our 0 count is still 1. Our 1 count is now 1. And we see that these two are equal. So we'll call this max of 2. We'll add them together. Okay. Now we go on to the third one and we increment our 0 count. So now we've looked at all three. But that's not enough. We also have to do like every permutation of this. So what we do is go back to start here. But I don't want to do that because I've already done this work. So I don't want to just kind of recount these things. So how do I prevent recounting? I think keeping a table is the right approach. What can we do? Could I subtract 0? Yes, but that doesn't help us get like middle values. I don't know, I think I'm just gonna brute force it. Otherwise we'll be here all night. And this problem, I don't know. I might have to just think about it something longer. I have gotten off on a bad foot with it and I'm just not doing so well with it. Alright. You know, even permutations are gross. I hate doing permutations. I always forget how to do them in code. If I had to say my greatest weaknesses in coding challenges, I would say permutations and dynamic problems. I have a better time with graph problems than I do with permutations. For whatever reason. But we'll figure this out. I really hate doing that. There's got to be an easier way. I'm going to look at this problem and see if this is considered an easy problem or not. Because if it's easy, I'm doing something grossly wrong. I'm thinking about the problem wrong. Okay, it's a medium. Thank God. Okay. Okay, I feel better. I'm okay with struggling on a medium. Okay. That is informational. It makes me feel better. It makes me think that there's not like just some like one-liner that I should be seeing. That's true. That's true. Let's just do it. Okay. So to pseudocode this out, we're going to look at every possible subarray. And just to kind of write it out, that's going to mean like if we have that, it'll mean looking at 0, which we know we can throw out anything with 1. 0, 1. 0, 1, 0. I'm already regretting this being so long. So let's just cap it at 4. 0, 1, 0, 1. 1, 0. And 101 and 01, and then finally 1. That's a lot of work, but we can see basically the balance is 4 there, balance is 4 there. We're actually looking at the same. Yuck. That's how you know there's a better solution. And yeah, that one's 2. That one's also 2. Alright, so that's a working solution. So now I just got to figure out how to do the stupid permutation. And I think permutation might be the wrong word, because in this case we do care about ordering. So what's the other word for permutation? Jumble? Man, my feelings are hurt. This is so upsetting. Alright, anyway. Stop length. No ice cream for me tonight, that's for sure. Yes. Yes. So if, Ryan, hey, buck out on odd. Sure. I'll clean that message up in a little bit. Okay. This is not, oh my gosh. That's not the way to do a permutation. It's not an n-squared algorithm. A permutation is not 2 for loops. A permutation is like n times n minus 1, or n to the n minus 1. That's, I mean, that's a polynomial problem. That's a horrible problem. Oh my god, I think I'm going to Google this. Yeah, I'm going to Google this, and then I think maybe tonight or some other time I'm going to kind of look at maybe some permutation problems and get some practice here, because this is, if I don't know how to do a basic permutation programming, then that's a problem, because these kind of things do come up. You see this description here? Programming by permutation is sometimes called programming by accident, or by try programming, or shotgunning. It's basically testing all permutations to see how it goes. So that's pretty funny. That's a big diss there, Wikipedia. Thanks. All right. I want to see the answer. I don't want to see. Okay, phew. Sure. So that's a traditional permutation where it actually swaps everything around. I don't want to swap. I just want to look at all the combinations. Combinations. Combinatrix. You don't need to know the exact number of 1 and O's, but rather just if the running sum has been matched before previously. Interesting. Let me think about that. Is it enough to know the sum, or do I have to know like the ratio? Because I don't need to know the total. Let's look at that. Oh, I need some of that stuff. Here we go. So we got 0101, sure. In this case, the running sum would be 0, 1, 1, 2. So how do I know that that's 4? So if we had a 5th element here, then my answer should still be 4. Could I do a stack or something? No, not a stack. Maybe something like a stack. Could I have like two stacks, like a 0 stack and a 1 stack? Let's try that. And then we look at a bunch of stuff. Oh, that's too many. Let's just look at the smallest case. In this case, I would say, hey, we saw a 0. Hey, we saw a 1. Okay, cool. Max is 2. Actually, let me do it this way. Say, hey, these stack sizes are the same. Cool. Our length is 2. Oh, 0 is -1. Interesting. Oh man, Ryan, that's good. Okay, I'll look at it in 1 sec. Let me keep thinking about this here for a second. I think this is kind of what you're talking about. Like, I think this, like what I'm kind of going after here, kind of makes sense. So we say 0. We push the 0. We see the 1. We push the 1. We see the 0 again here. Then we pop the 0. Ranko, throw me a lifeline. I think Ryan's got a good lead here, actually. I am just dying on this one. This one is beating me up to pulp. Trying to find the longest contiguous subarray with an equal number of 1s and 0s. And I tried doing like a cool tree solution, depth for first traversal with the inline array, and failed spectacularly because I missed like a important use case where it goes over the top of the tree. It just didn't work. All right, Ryan, I'm gonna take a look at doing what you said. Make sure I understand this. So if I see a 1, I'll add 1. If I see a 0, I'll take away 1. And we'll keep a running sum here. So 0, got -1. And I see the 1. So at this point, I've got 0 because it's balanced. Okay. And then I see another -1. And I get a -1. I wonder if I could count the number of 0s. Count the number of times I've seen things balance out, if that makes sense. Oh my gosh, is that it? So if we say 0s are -1, 1s are 1, then every time we hit a 0, not counting the first initial state, then things have been balanced, and we can count that. Let's try it. So -1, it's like we got a -1 charge. Let me see the 1 and adds 1. So now we're at 0. So we say, hey, balance. Okay. And ultimately we'll time this by 2 because we know in order to balance you have to have even number of sides. And then we get another 0. It's a -1 charge. We're out of balance. So we know that our answer is 2 times balance. Now does that work if we have some garbage in the middle here? Hash the index and sum, yeah. Okay, what is this? This answer should also be the same. Or if I put some stuff on the end there, I don't know, we'll see. We'll see what happens here. So -1, 1, balance. So 2 is, we've at least got an answer of 2. Okay. Now we go -1, so we're back down to, oh sorry, we did -1, got it to 0. Okay. Let me write this as the, geez. I don't have a good way of writing this. Wishing I had to add commas. All right, so I'm just gonna keep our running sum here. So it's -1, 0. That's how we got our balance. We're back to -1, back to 0. So now we know that this is gonna be 4, because we've now seen that happen twice. We've seen balance happen twice. And now we've got a bunch of zeros. And this is where things kind of fall apart. See what I mean? So we keep going down, 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 down. But then we come back here. It's almost like we just need to kind of give up and reset. So how do I know when to give up and reset? And I mean, this would be fine if there were a bunch of ones coming after the fact. So I can't just like truncate that data, right? So you say has to index and sum, yeah. Check if your current sum is greater than or less than the plus minus 1. I still think we run into a problem. I mean, unless I'm misunderstanding something, if we have like a big imbalance here, then it basically will never recover. So in this case, we'll never get back into balance. So we'll say that the max is 4, but really, if you look at the end of the string, it's got 6. Actually 8. Continue from when you were broke. So make sure I got that. We say -1, 1, -1. Oh, geez. -1. Balance the force. So result equals 2. -1 again. Balance to the force. Okay. Now what? At this point we go -1. And then we go -2. And that means that we need 2 ones to balance this out, which is fine. Maybe we'll even get them. So it's like I kind of need to know to basically lob this off into its own thing. I don't know. I'm thinking again about brute force. And you know what I said about the permutations being annoying to do? This is not a pure permutation problem. This is a combinatorics problem, so it's n squared. So man, peeps, I say we try brute force. Nums.length, just see if we can get a right answer. My soul needs it. Old friends I and J here. They've gotten me out of so many jams. And we are in a jam. What time is it there, Dave? We don't want to set it. We want to set it equal to I plus 1. Because we don't ever have to worry about that. So now, if 1 a.m., oh my gosh, where are you? Oh, you're in the UK. Oh, I see. I think I see what you're saying, Ryan. So basically you would look for that spot later on to know if that counted or not. Oh man, I'm just not quite seeing it. Like I think I kind of get you. Okay, Dave, we're gonna bang through this. We're gonna see this through. I'm gonna try and hurry up for you so you don't fall asleep at the keyboard. And also, if you go to bed, that's totally cool. That's a good idea. In fact, you should go to bed right now. You have work tomorrow? If nums at I equals... No, wait. Ireland. Awesome. Man, I would love to go to Ireland. Oh my gosh. Oh, I would love. I used to play video games with a guy named Ronan in Ireland. One of my coworkers lives in Ireland, actually. Let's see. Even this is kind of confusing, man. So, what I want to do here... All right, Dave. Let's see it through. I'm even right now, I'm just like... I'm just kind of spent. I've already had my day of work in. You've had your day. So, I'm pretty tired. It's only 8 p.m. and I'm ready to go to bed. This problem is just beating me up. We're going to get it. Oh, man. I might take you up on that. Pints are big, though. We don't have pints in America, usually. I'm a little scared of the pint. I need a little, like, 8-ounce bottle. A baby bottle. We're going to slice from I to J minus. Alright, so that will get me an array, but that, I mean, that's just gross. There's got to be a better way to do that. So for every item, what we'll do here is we'll initialize our counts here. I owe you a pint, Dave, for the the horrible mess I made you look at. One count equals 0. Okay, and what we do here is if nums at I equals 0, then 0 count plus plus, else 1 count plus plus, and if 0 count equals 1 count, then we return, or no, we don't return. Got to keep the max. 500 milliliters. Wow. That's awesome. Let's see here. My godfather's Irish. He goes over there. He's been over there several times, actually. He needs to take me, dang it. 0 count equals 1 count. Then, if 0 count plus 1 count, sure, is greater than max, then we'll set max equal to 0 count plus 1 count. And we will just look at everything. Every time we basically start up a new index here, we do that. So I think that's good. This is the n-squared algorithm. It doesn't... what I'm trying to say is the memory footprint is constant. Oh my gosh. I'm running out of steam. Let's return the max and then forget about this problem forever. Okay. No, total wrong answer here. So it never changed the max here. Nums.length. Nums.length starts at I plus 1. That's right. If it equals 0, we increment that. That all looks good. Say if 0 count equals 1 count. Sure. If that is greater than the max, then it should have set the max. Max is outside the loop. That all looks good. Okay. So, what did I do wrong here? Let's see. Console.log nums at I. That'll be the character that we're starting at. And that will go through every item. Set those equal to 0. Set you equal to the next one. We run all the way to the length. If you're greater than negative infinity, then I mean, what am I doing wrong now? This has got to be right. How is the max never getting set from negative infinity? It's like even, I mean, that would only happen if this never got updated. Oh, well, I mean, for one, I'm looking at I instead of J. So, wow. And I should be looking at I. So, good news. I think that was the problem. Let's try this again. All right. Hey, that looks good. And that's the one that was giving us grief. Let's try those other test use cases. Okay. What about this one? This is the only other case we looked at. Did we get the right answer? Yeah. So, yeah. Shall we run it? Submit this baby. We're getting judged. It's taking a long time. Wrong answer. No. Okay. Dave, you mentioned this earlier. Setting negative infinity. No good. Aside from that, I think we got it. But man, I never get things submitted the first time. I always try, and I always manage to miss it the first time. I'm definitely uncomfortable with how long this is taking to run, as well as how long it took me to solve a medium. No. No. Let's try it again. So what I think is happening is because of my terrible runtime of O(n squared, it is it's timing out. It's not finishing the problem. It's giving up on me. Oh my gosh. So this is the input they're throwing at us. Wow. So, man, so much for brute force being easy, huh? Okay. So here's the brute force solution. I believe it's correct. It's just terribly slow. What to do about it? I mean, I am doing the same comparisons over and over and over again. I'm doing the same additions over and over. I'm counting the same items over and over and over. Why am I doing that? Exiting early isn't really going to help, like looking for, you know, kind of signs that I'm never going to get to the end. I need something that's going to change the big O time here. I need to get this n squared down to, you know, n log n. N times the logarithm of n at a minimum in order to get this thing to run in an appropriate amount of time, I think. So what does that mean? usually when I think about log n, I'm thinking about, you know, sorting. But that's not going to help us here because it has to be contiguous. I think a dynamic solution is the way to go. So Ryan, I'm looking back at you. Make sure I understand what you're saying. If you keep track of the sum, if the sum reappears later on, then you know it was balanced between two spots. So I'm going to take what you said there, Ryan, and think about it. With an arbitrary example, a couple arbitrary examples. So if we take 0, 1, 0, we'll do the -1, 1 trick. So the sum here is -1. Uh, 0. So result 2. And then we get to -1 again, and that's fine. Now I do see the same result here and there. What does that mean? Hey Abdu, yes, I'm having a terrible time with this one. So, given a binary array, I think that might work. Given a binary array, so the elements are either 1 or 0, we need to find the maximum length of a contiguous subarray with equal numbers of 0s and 1s. So for example, what I'm looking at here, 0, 1, 0, the longest contiguous subarray that has both a 0 and a 1 is either these two, because we've got a 1, 1, and 1, 0, or these two, which is the same thing, 1, 1, 1, 0. So the question is, when you get input like this, whoa, too far. This, what's the greatest subarray that is balanced? And so we started by doing a tree, a binary tree, and you know, treating the array as a tree basically and counting. But the problem was I had a logical error where I wasn't properly dealing with the peak of that tree, so if it crossed over the root. And so it was a fallacy that basically caused me to toss the whole solution, so I wasted a ton of time. And so then we said, well, screw it. Let's just do the brute force solution. So that's what we did here. And it looked like it was working, but the problem is we exceeded the timeout on LeetCode. And this is a medium problem, so I feel a little better about that. But still don't feel great about taking so long on a medium problem. I would not be getting a job offer from Facebook right now. So I was trying to kind of rethink about this problem, and I do think that I think Ryan's on the right track by oh, there's two Ryans. Hey, what up? By basically keeping track of kind of the sum, and then we could almost like kind of look at the high watermarks to know when items are in balance again. But I just don't know. I don't know. I'm having a hard time seeing it. So I do think the answer is going to be some sort of like dynamic solution. I don't think it'll be greedy. I think it's going to result in some sort of table that we kind of update as we go along. And we add some things, sometimes we subtract some things sometimes, and at the end of it, we basically keep that high watermark. So if I look at an array like this, then what we said with the kind of the summing trick is if we treated zeros like -1s, then if we throw the sum into a dictionary with the index, Ryan M. Yeah, let's see what that gets us. Okay, so let's memoize this baby. Huh. Yeah, what does that mean? So in this case, we have a 0th item. would be a -1. The first item would be, as we're going to keep the running sum, a 0. Second -1. It's basically going to toggle back and forth. 3, 0, 4, -1, and that's just going to keep on going like that. So how does this get me the answer in this case of 1, 2, 3, 4, 5, 6, 7, 8? So we talked about basically counting up the number of zeros and multiplying by 2. So 5, 6, Jesus, auto tab, 7 and 8. So in this case, we would have seen balance 4 times. And so we could take the number of times we saw 0 and multiply by 2, we get the right answer. The problem is if we have like something that messes it up like that, and then you know, something like, well, even if we had a bunch of 1s, it still kind of messes up, because what happens is this number is going to keep getting more and more negative, tracking those zeros, and eventually it'll start coming back up, you know, -5, whatever, and it'll eventually get back to 0. But it's not enough for me to just count the zeros. I actually need to like kind of measure this gulf between zeros. So maybe that's really the solution. It's not that we're just blindly multiplying by 2, but rather we're measuring the spaces in between those balances. So if I say like, hey, how many elements are between here and there? Then that's pretty interesting. That lets me go through the array once, keep a running sum, and then I can go back and basically go from like, hey, yo, from you to you, how much space was in between you? In this case, though, I actually need to know to go back even further. So I don't know, that's still kind of weird, but I think that's getting close. And really, if we're keeping a dictionary with the index, then it's really not any different from another array. So if we bring it back in, keep it small. We kept an array and we said, you know, basically out of balance, in balance, out of balance. Then I need to be able to say, hey, out to in, or out to in. The first time and last time you see a sum. Yeah, okay. What does that look like? We'll do this. I think I made that balanced. Check the first and longest comparing and update every time we had a subarray longer than the tracked one. Yeah, so I think that's what I kind of did here, Abdu. But if I'm understanding correctly, it just it ended up being too slow. So I looped through everything, and I would keep track of whenever I saw like the biggest. Yuck. So I think you're on something, Ryan. So we say, hey, this is the first time we've ever seen -1. Then 1, say the first time we've seen 0. Then we need the second element. Now at this point, we are seeing -1 again, but I've already got that here. So what's interesting about that is that tells me that I can collapse this. Is that true? Not quite, but it's not that far off either. So I can't collapse between -1 and -1, but I can collapse between zeros because those are times when we're balanced. So if we keep going on here, so here we added 1. So because we're balanced, I'm able to kind of delete these and put a 2 on. And say, hey, the range from 0 to 1 is balanced of 2. And then we move on and we say, oh man, that's interesting. This reminds me of a stack. What if we thought about it that way? So on a stack, we see 0, we see 1, it balances, so we pop them both off and record a 2. I guess I can, I don't know, it kind of, I need a signal to let me know that basically I don't have to think about that again. So my stack is back down to 0 and I've got a 2 here. Okay, we've moved through those 2. All right, now I'm going to push the 0 and a 0, 0 and a 0 and a 0. We're going to push a 1, so these cancel out. I push another 1, this cancels out. Oops. I push another 1, this cancels out. I push another 1, that cancels out. I push another 1, that cancels out. And at that time I can record because I hit the root. So yeah, let's try that again. So this X will represent like the, whenever we hit home, whenever we've hit balance. So we push the 0, push the 1. We've hit balance because these cancel out. So we have at least one contiguous one solution of 2, one subarray of 2. Okay, we push a 0 now. And a 0 and a 0 and a 0 and a 0. We push the 1. So we see a subarray of 2. Okay, pop those off, push another 1. We see another subarray of 2. Push another 1, subarray of 2. Yada yada, you see how this is going. Okay. So at this point, every time I did that, I could basically collapse this as well, because there are no imbalances in between. So let me try this again, rewriting it that way. Here's our root. We push the 0, we push the 1. So now we've got a result stack. Sure, R and S. And we'll push a 2 to signify that we've got a contiguous subarray of 2. I don't think this is going to work. I don't know. Still thinking about it. So because these match, I'm looking at it. If you're running sum at index 50 equals 26 or something, then you can keep counting the running sum. If you see running sum equals 26 at index 122, you know that in between index 122 and 50 we're balanced, and so I can bring that whole thing in. All right, Dave, I'm sorry. I let you down. I owe you a pint. Man. This is so painful. Why am I having such a hard time? All right, Ryan. I think that you know the answer and you've had the answer for a long time, and I'm just not understanding what you're saying. Ryan Costco. Let me take another look at this again. If the running sum at index 50 is 26 or something, you keep on counting the running sum. If you see 26 again at any other point, you know that you've got a winner. Sure. So this is balanced, I believe, and this is going to be a big balance. So let's see what that looks like if we do things that way. So we're still talking about doing -1 for the zeros. Okay. So our running sum is going to be -1, 0, -1, 0. Oh wait, I think I went too fast. No, let's just keep it -1, 0, -1, 0. And then we got 4 negatives. Okay. And then we go 4 positive. Then we go 1 more negative and 1 more positive. So what does this mean? What does that mean? So, is it simply a matter of taking the biggest number minus the smallest number? No. Keeps track of the index. So I know the index we were at because the indexes still line up. In reference to a hash or dictionary. So that's where I get kind of lost. I mean, if I understood correctly, did I do this math correctly? Is this how the sums should look? And basically at every 0, I know that we are balanced. So in this particular answer, the result we're looking for is 14. So how do I get 14 from these numbers? The biggest I ever got was 0. And the lowest I ever got was 4. Okay, I think I probably said it before you asked. But the result is 14 that we're looking for. So somehow, say expected. Not every 0, every repeated number. Okay, so if we looked at every repeated number. So we've got one here, an index 0. Every repeated number. Okay, so let's try it out. So we've got a -1. And so if I understand you correctly, we'd have a hash that says something like -1 and say, hey, we got one at index 0. Am I on the wrong track there? Then here, when we saw the 0 the first time, we'd say, hey, you got one at index 1 there. And we get to -1 again. Here I would say, hey, you got one at 0 and you got one at 2. All right, and then we go back to 0, we get another one at 3, And here we go 4. Huh. Okay. Interesting. And here's where things get a little weird for me. So 2 is going to be 5. 3 equals 6. Negative 4 is 7. And then we start going back down. So this is 8, 9, 10. We get 11. And then we get 12, which means I missed the number in here somewhere. No! So the negative 1 should have been at 0, 2, 4, and then 10. This should have been 11. Okay, so whenever we get a match, we should see if the distance between those 2 points is greater than the current max contiguous array. So here we got a match. Oh, interesting. So here we got a match. So it would have been 2 that were balanced. But what's freaking me out is, I mean, this isn't balanced. That's 3 elements. Oh, but it does contain a 2. Okay. Okay, so whatever. When we see the negative 1 the second time, we would have put it on here and we would have seen, oh, okay, 2 minus 0 is 2. So our max is 2. All right, and then we would have seen a 0 here a second time, and we would have done 3 minus 1, and we've gotten a 2. But how do I know that these could have been connected? Let's just keep going. So let's call these the max contenders. All right, then we got another negative 1. So this time we got a 4. Is it 4 minus 2 or 4 to 0? I guess it would just be 4 to 2. Then we got a 4th 0, which is here, right? No, I did something wrong. The next number should have been a... Did that? That was the third negative 1. Should have been negative 2, which is new. That's fine. So new max contender. Then we went to 3. No new max. We went to 4. Okay. We went back to 3. So we can add in negative 2. Okay. Then we go back down to 2, and we can add in 4. It would be 4-0. Oh, so I would go all the way back to the last O. Okay, so that was the 4 there. So here is where we're down to 11. Or 10 rather, so that would be 7. You only keep track of the index where the first running sum happens. Okay, I see. Okay. So I'm just going to do this thing over again. And hopefully do it right this time. Alright, let's try this. So. First we get a negative 1. And we store it at 0. Alright. Then we got our first 0. First balance. Yeah, sorry Ryan, I hate that. I don't know how to fix that. The app I'm using is kind of weird. I'm using Streamlabs OBS. Okay. So 0, the index is going to be 1. Now we come back because we're at this 1. So we add in a 2. That's fine. Here we get a 3. All right, now again we get a negative 1. So here's what you're saying. It should have been a 0 and a 4. All right, then we get a new item here. Negative 2. And its index is 5. Negative 3 is 6. Negative 4 is 7. Those are all new. Then we get back here, 8. That's fine. 9. That's fine. And here we get 10, but we should remove this 3. Okay. And that was for getting us down to this 0. Oh, I forgot. Okay, this is where I messed up before. Let me sort this a little bit differently. Okay. Oh my gosh. Okay. 9. I don't remember what the last 0 we saw was. It was 4. Okay. 0, 1, 2. Sorry, it was 3. So this one becomes 10 and 0. So that's what I was missing before. So because of the delay, you're probably screaming this at me. But I think I got that correct now. Okay. But now this is where things get cool, because now we get a new one, and this is at 11. So we erase that 3, pop on an 11. We got a negative 1. So make that thing at 12. And then we get another 0 at index 13. So if I did that right, it's close. It's very close. Did I count correctly? 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14. So there should have been a total of 14 because it is totally balanced. With 7 zeros. Yep, and 7 ones. Man, this is so close. This looks really good. But yeah, ultimately I'm basically looking at the span between here and there, or here and there. So it's always off by 1. Yeah, index 0 has a count of 0. Been using negative 1s, but I guess we don't really need to use negative 1, right? I don't know. Yes, we do. So this is index 13. So what we're saying is basically this should have been almost like a negative 1, right? That would have gotten us the right answer. I could also just add 1 on the end. Is that really the solution? Gives us the right answer. It's not a coincidence. Let's try it on a smaller solution. All right. So, sorry, expected is 2 here. Okay. So what we're going to do is we're going to do the same trick, and then we're going to remember to add 1 at the end because we're kind of starting at 0. Or, I don't know, we'll hold on that. Okay. So, as we iterate through, we start with negative 1. Okay. So negative 1, we have an index 0. All right, then we add in our 1, and we get a 0 here. Okay. At index 1. This is weirding me out, man. All right, and then we add our third item, which is a 0. Which brings us back down to... Oh, I did this wrong before. Sorry. That brings us down to -1 again. So, in this case... Geez, this should have been 0, 1. So that's the right answer. So it's 1 minus 0 plus 1 for the being off by 1. But I don't know if this use case is going to work. So let's try this again. So this should be expected too. Maybe this is a special case we just have to watch out for. So here, our first item is -1. So in our little array here, keep -1. And then, oops, we go to 0. And what's weirding me out is that 0 to me means balanced. So in this case, the answer should be 2. But I don't have any... But we did say there was kind of like a imaginary 0 here. Which we kind of said, we, you know, basically kind of, it's like pre-populating this in order to get things to balance. But then we don't need to do the +1 trick, which is fine. Because 0 is the initial starting point. So, man, I think you got it right, and I think you've been right for a very long time. Thank you for your patience. I'm just gonna double check a few more things because it's still just boggling my mind. This one is. I'm glad you're here because I don't know that I would have gotten this. I'm still struggling with this. So if you have any tips for how to do this, it's like dynamicifying this stuff. This is definitely like the kind of textbook dynamic solution. You create a table, you keep track of stuff as you go along. And then at the end, you magically have your answer. But man, this one is just melting my brain. Yeah, it sure does. All right, so feel good about this use case. So I'm going to go back and try this one again. 0, 1, 0 use case. Expected answer is still 2. And I'll get rid of that. So this is our cache. So what we do here is this time though, I'm going to write it out explicitly. And we say there is an implicit -1. And the reason it's -1 is because we've kind of been saying like, it's kind of like positive negative ions. So like our zeros are kind of -1s. So we're saying there's like a -1 index -1, which just makes the math work out well. So that's how we start this. This is our seed. So then we get a 0. But doesn't that bring it down to -2? No, because okay, sorry. My bad. Ignore that. So we see this, it's a -1. So that's our running sum. No, I still did something wrong. Here, let me not do that. Let's not seed it again, and then I'll figure out how to pop that seed in again. Sorry, I am just struggling with this one. So we got -1. Our first spot is a 0. And then we get up to balanced. So add 0. Add index 1. Jeez, I'm going crazy. And then we go -1 again because we added the 0. So -1 gets a second value here. So 2 minus 0 equals 2, so that's good. So I think here is probably where I should have done the pre-seed. So let me try that again. Sorry, I keep going over this over and over again. I don't want to code the wrong solution again, you know? All right, so here we expect the answer to be 0. This is the data we're seeding with. All right. Let me get rid of this stuff. Just noise. All right, this is our array, 0, 1. We're looking for 2. We pre-seed with the -1 index for 0, which I still feel weird about. We seed in a 0, so we set our charge to -1. We see the 1, we bring that charge back up to 0. So what that means is that we record -1 at index 0, and we record a 0 at index 1. All right. Now, 1 minus -1 equals 2, which is the right answer. So, let's try this again for another input. Because I still just have a hard time really grokking it. You know? I'm just having a rough night. Okay. So we got our 2. We've got our seed by saying, you know, balance is -1. So this time we've got a positive charge. Which brings us up to 1. So in here we pop in a 1. So you initialized hash map at 0 at 0 and started your for loop with 1. Nums and enumerate. Nums 1. Okay. So I'll try that in a sec. Let me make sure I did this one right. 1 is at index 0. All right. And then here, the -1 charge is going to bring us back down to 0. Which is index 1. So, I mean, I'm telling you, Ryan, you are right. I've tried to disprove you several times, and it sounds like you've even solved this problem. So, you definitely know what you're talking about. I'm just having such a hard time kind of grokking this one. But I also don't seem to be making a whole lot of headway in really kind of understanding it. The seeding is throwing me off. I don't know. So did you do like plus or... No, I guess you could do -1 and 1. That's probably as good as anything else. So let's do this. Const cache equals... We seed our 0 at -1, which is the same as doing what you got, I think. I think I did that right. Okay. For let I equals 0, I less than nums dot length I plus plus. Cache at, oh, I need to keep my sum, and the sum, we start off with 0, and I guess that's where the -1 kind of comes in. It's like, then kind of justify that way, although it's still very strange to me. All right, so if nums at I equals 0, then sum minus minus, else sum plus plus. And we basically say the cache at our sum is either equal to, if it exists, then that +1, otherwise it's, no, it's not. That's not true. So if we've never seen this sum before, then we set it to the index. If we have seen it before, then what? Then basically I could do it like this. I mean, this is not a great solution, but I think it'll work. It's going to spread this out a little bit. If we've seen it before, then basically I want to clear out everything but the first value. Dot sum. And so I want to slice everything. Cache dot splice. Basically everything from 1 on. Dot length -1. That's pretty gross. What I'm about to do is even grosser, maybe. If cache.sum is greater than 1, then we'll just pop the last value off. Gross. And then cache.sum. Oh, geez, I'm an idiot. Okay, sorry. My brain is melted. We're going on. Oh, we are over 3 hours now on this problem. Oh my god. Terrible. If cache.sum at 2. Current index is greater than the max distance. Oh, you're right. You're right. Yeah, I don't need to keep a cache. Good call. Good call. All right. So, I do need to know a max. Okay. So nums that I only ever tracks the last one, or the first one that we've seen, which is good. So that's fine. So if nums that I exists, then we can check our max. So if, sorry, not nums, cache at I, and it's not cache at I, it's cache at sum, geez. If the cache at our sum exists, then we need to check if our nums at I minus our cache of sum is greater than max. If it is, then our max becomes this beast. Otherwise, cache at sum equals nums at I. Then we return max. So Ryan, you have any tips for dynamic problems? I'm definitely, oh sorry, ignore that, that's from a prior run. I am definitely struggling with this guy. Sum is not defined. What did I do here? Oh. I do need the sum. Yes. All right. Have any tips for getting into dynamic programming problems without too much pain? Because I would definitely say that this is painful. All right, that was correct. Let's try the other use case they gave us. correct. Let's look at the use case I was worried about. 1, 2, 3, 4. 2, 3, 4. 1 and 2. Oh man, I think that delay is awful. Oh my gosh. Maybe I did do something. You said need to keep the sum variable, yes, and also max should reference the index, not the num of index. You're right. Yeah, because that's always going to be 0 or 1. Let's try this again. Did I not click it? Nope, I still have the wrong answer. So maybe I goofed something else up here. So I cached the sum the first time I see it. Oh yeah, and I should be looking at, no, that's right, the cache of the sum. And if I minus the cache of the sum is greater than max, then max equals I minus the cache of the sum. I gotcha. Sounds like I still got it wrong. I think I'll eventually, the lag is killer. I think we eventually got to the same spot. So let's try everything together now. Sure. Awesome. All right. We're going to do this. Drum roll. Ryan Costco. You saved me. Wrong answer. No. 001. Seriously? So I probably still have a typo somewhere. So they expected 2, which is good. So what did I do wrong? If nums at I equals 0, sum decrements. Okay, otherwise the sum increments. If cache at the sum exists, oh man. This might be a JavaScript thing. Should say if cache at sum is not equal to undefined, or all right, I'm gonna have to check this. I don't really do a lot of JavaScript in the day job anymore, or at least I should say lately. So it has. So I get undefined, which is what I want. What I'm afraid of happened here is basically it checked to see var x equals. Sure. So now if I say x at 0, it's 1. Okay. Geez, this is not a good one. Var x at 0 equals 0. Yeah, that's what I'm thinking. Did falsy bite me here? Oh my gosh. At this point, my brain is just scrambled. 0:0. That's what I'm trying to check. So x at 0 is 0. If this, then console.log really. Sure, dang it. Yeah. Say x at 0 equal null. It's false. X at 1 equals false. Undefined. Undefined. So, bring it back to the actual problem I'm trying to solve here. If, I just want to know, there's got to be an easier way to check if it exists. I guess I don't typically have I don't usually check for zeros like that. If you're undefined, I gotta swap this stuff now. Sure. I don't like doing knots. Else if that. Yeah, I like how that worked out, I guess. Alright, let's try this again. Got the right answer. Alright. So let's try submitting this one more time, and this is going to be it. Oh my gosh, the Ryans saved me. Thank you, Ryans. Alright. Immortalize this. Alright, let's see how the runtime is. I think this is going to be super good. Yeah, that's what I thought. Look, like all the solutions are, that's crazy. That's I've never seen a distribution like that where like so many of the solutions here, and then here's the person that I was trying to be where they like eked by probably with the n squared algorithm, but it just happened to run fast. So like I think you can pay to have your stuff run faster if you do the pro account. And so I wonder if they did. So let's look at it. Because Ryan, you taught me this trick too, Ryan Costco. You can click here. I got this new gaming mouse and it's too precise. All right. So here we are. I don't know, they're doing something a little different. It's not that. It's not as crappy as the brute force solution I came up with. Alright. And the tippy top answers. How's that look? Hey, you look familiar? Yeah, man, I clearly have a problem with dynamic problems, so I don't know, maybe I'll do some Googling or something, like try to find just some easy dynamic problems and kind of build up there, because, you know, I don't even think I can blame that one on being rusty. I just wasn't seeing that one. And there was another time I had an interview once where I had a dynamic problem, and I just couldn't see it. And I had actually done a problem that was really similar to it before, and I just could not see the solution that day in the interview. And like the problem that I'd solved before was literally like a week before it, and I just could not get to the end. It was brutal. It was brutal. That was the only interview I ever had where like I just plain failed at the problem. That was terrible. So I would have failed this interview. I would have just bombed it. Even after you like literally like drug me through it, Ryan, I just was not seeing it. So thank you for getting me through that, and I've got some work to do. And that was a medium. Woo. All right, well, hey, that's what we're here for, getting better at this stuff. So awesome. Hopefully tomorrow goes much better. Rod cutting. I don't think I've ever seen that. Given a rod of length n inches and an array of prices that contains prices. Okay, just making sure my eyes weren't going bad. We are talking about pieces and prices. Given a rod of length n inches and an array of prices that contains prices of all pieces of sizes smaller than n, determine the maximum value obtainable by cutting the rod up and selling the pieces. Okay. Oh man, yeah. For I used to always think that I did tree problems really well. I like that Paul Bunyan. I'll remember that one. Paul Bunyan of tree problems. But then yesterday I had a rough time. But yesterday's problem, I just did a heap from memory, and I was just foggy. I was just rough on it, and so I goofed up my percolate down, and then I just got caught up in the debugging. I definitely don't love coding in LeetCode. It's like normally for something like, not so much today, but for yesterday's problem where I was trying to do a heap, I would have written unit tests for the heap just because it was easy to something to kind of throw a couple tests together and do that. And Code Wars is really great for that. You can have a little area for your tests and you can write them. And LeetCode, you just have this little box where you put in the kind of the questions and it runs your code and their code and compares it. So this is good too. You know, there's pros and cons to both, but I definitely miss being able to just like write some tests for my sub functions. My wife calls it stubborn. Maybe pig-headed when she's feeling nice. So yeah, well, I thought I might do a bit of Beam programming tonight, but that's not going to happen. I'm going to take a break and then maybe play some Overwatch. All right, so thanks for sticking around. And I owe everybody in here pints. Ryan, Ryan M, you're right. I really should just code and view in code. I think I just was doing it in this editor because, you know, I don't know, kept it all on one screen. But it really has not made my life any easier to try and just do it in this little box. So, and even in JavaScript, I haven't written a line of JavaScript like professionally in I don't know, maybe a year now. I just haven't really been doing that much. I used to always do like kind of 1/3 SQL, 1/3 JavaScript, 1/3 C#. But lately, the last year or so, it's been like, I don't know, 3/4 Kotlin. And I'm not complaining. I like it. But I'm trying to get back in touch with my roots. All right, I'm going to head out. Thanks for sticking around. Hey, have a good night.